Can you give me a set of 4 collinear points in this diagram, please? Okay, nice and easy. A, C, D, and B, these 4 points along this top line, do all fall in the same straight line. Okay, there's another possibility that could have been picked here. What would the other possibility be? Good. So H, F, J, and G is the other possibility on that. So as long as you picked one of those two, you should be good on that. Okay. As far as the second question, a set of 4 non-collinear points. Andrew, what would be a possible set of non-collinear points? Okay. So H, M, K, G. And so here's H, M, K, and G fall on a completely separate line, so that works. Again, there's an almost unlimited number that you can pick from there. There's plenty of those to choose from. Okay. All right, questions regarding collinear, non-collinear? Again, pretty straightforward. All right, for sample problem 5, Kylie. So A, I, and which ones? G, K. All right, you went right for the challenging one. Good. Okay, so A, I, G, and K. Here's A, I, G, and K. You can see right here, these are contained in a single plane. It's this blue shaded plane. So that set of 4 would be considered coplanar. Okay, very good. This is one, you want to be able to see this. I can guarantee you're going to get questions that have to do with these diagonal planes that aren't actually drawn in the figure, but that do exist. So make sure you can visualize those and pick them out. All right. Let's take a look at our question B on this. Yeah, Matt, question.
Well, actually, I had a question about question A. So you wouldn't be able to do ACDB?
Yes.
That's not a
No,
plane.
So the question is, are A, C, D, and B considered a set of 4 coplanar points? Yes, they are. You can, as long as they're contained in one plane. So A, C, D, and B, you could think of that as being contained in this upper plane, right? You could also think of it being contained in B, K, M, A. So there's multiple planes that contain those. They'd still be considered coplanar. Now, the distinction in that is they wouldn't be able to determine a plane because they're in a straight line. But any number of points in a straight line will always be coplanar. Okay. All right, so John, back to you. Problem B, what would be a set of 4 non-coplanar points from that diagram, please? John, what would be a set of 4 non-coplanar points? Yep.
Oh. MKGL.
Okay, so M, K, G, and L. Okay, anytime you're looking to test these, so if we say M, K, and G, M, K, and G define or determine this bottom plane. Okay, and the question is, does L lie on that plane or off? The fact that it lies off gives us the non-coplanar set. Okay, so very good. Again, there's other possibilities beside these answers for A and B. These are just an example of each one. All right, Nebs, you have this final question. Name 3 points that determine a plane in this diagram, please. Okay, so when you look at this, A, B, and I. Okay, so A, B, I determine this upper plane. Okay, it distinguishes it from any other plane. No other plane can pass through those 3 points, so that is an accurate answer. Okay, again, you could pick any combination of non-collinear 3 non-collinear points from any of those faces to determine a plane. All right, are there questions on those 2 problems?
Yeah, okay, so the plane ACI,
Uh-huh.
would that determine the plane?
AC and I would, yes.
Okay, but which plane? Would it be the top section or would it be that little triangle?
Well, so let's say if you draw the triangle that they make,
Yeah.
remember, because it's a plane, it actually extends infinitely in all these directions. And so extending this out, like think of it as like paint covering the, like if this was a block and you poured paint in this little corner and it just kept pouring just in that corner and it seeped out along here. So it's still going to cover this whole face here.
So with the top.
It's the entire top, yeah.
Okay.